Okay, hello students. So in the lab where you're trying to measure that turn-on voltage of the LED using the IV curve method, I wanted to give you some hints about how to get all that wired in. So this little device here is of course your 10K potentiometer. You turn this knob here, it turns clockwise and counterclockwise, varying the resistance. And so I always sort of start with it about sort of in the middle, get a feeling for what it does and put it right about in the middle so you have a decent amount of resistance on as you get started. And you may or may not remember this from electronics, but the way it works on the potentiometers is there's always three leads across them, and the resistance between two far leads on the edges like that is always the constant. It'll be 10K, the full resistance of the potentiometer. And in this case here, the 10K is actually sort of etched right here at the very top of the potentiometer. It says B10K, so I know it's a 10K, and that'll be what exists between these two far leads. The variable resistance comes from between the middle lead and either the left or the right lead. So you always want to be connected to the middle one when you want that variable resistance, and that's what I want to sort of tell you how to get going with to help your circuit building along, given the stuff you have in your kit and you're not in a laboratory with all kinds of cool supplies around. So what I would do is I get one of these hook leads again and hook that maybe right into the middle like this, okay? Because there's just about no other good way of getting a good connection to these relatively small loops that are on the potentiometer. Then I would take the black one and connect it to one of the side leads. So in this case here, I need to use a potentiometer in variable resistor mode, so I make two connections across the middle one and across either this one, but I just chose that one of the ends right there, okay? So what you can do now is the potentiometer can sort of be placed aside, and you can realize then that on these sides of the clip leads will always be that variable resistance. And so what I'll do to get into the breadboard is I'll sort of stick to the same color scheme. I'll connect a black wire to that clip lead and a black wire to this clip lead. And so I see, hopefully you see now, that when I have these two leads, these can just go right down into the breadboard wherever I want to place that variable resistor. And so if the potentiometer is just sort of sitting here and I need to change the resistance by turning this knob here, I know the resistance across these two leads is going to change, and that's going to be stuck right into the breadboard. And if you want, go ahead and put your voltmeter into ohm mode and clip onto these two leads here, and you can verify that for yourself. So at the moment then, I'll just take the potentiometer, place it out of the screen, just realizing that these two wires here will always be my variable resistance. So what I'll do now is I'll sort of say, well, all right, if you want to get this going with the LED circuit, you can start with a breadboard like this. And as always, I'll put a red and black lead on here to indicate where my power is going to come from, and I'll route those to the Arduino as I get started. I'll use the Arduino for power. So here's what I'll do. I'll take that red lead from the potentiometer, this one right here, and I'll connect it directly to the power supply. So that means when the circuit gets connected, the current's going to come out of the power supply and go through this red lead, through the clip lead, in through the potentiometer, out of the potentiometer, and it'll come out through this black lead here. So I can just get the black lead somewhere on the breadboard like that. Okay? So I know that the current is traveling through the potentiometer, but there is a significant amount of resistance presented. And so what I'll do now is here's an LED, and observing once again, looking for that flatness on the case, which looks like to me is right there. I'm going to put that LED into my circuit like this. Okay, there's the LED. So basically I have the current coming out of the potentiometer, out of the power supply, going into the potentiometer, back from the potentiometer on this black wire, now through the LED, and I'll just take another jumper wire and connect it, say, right there on the other side of the LED, and then over onto ground like that. So this is sort of my complete circuit for looking for that turn-on voltage of the LED. And just to make sure it's going to work now, I'll bring my Arduino over into the picture, and I'll put this red lead from the power supply into the 5-volt pin like that, and I'll take the black wire and plug it into the ground lead like that, so that it essentially powers the breadboard. And you can see that my LED is even glowing a little bit there already. And now what I'm going to do is I'll just come over here and I'll get my hands on the potentiometer like this and start turning it, and I can see when I do that, that the LED gets a little brighter, there we go, and a little dimmer. See, there we go, so it's actually working. Now you want to be careful about zeroing out the potentiometer, because the LED gets too bright, it'll burn itself out, and that's exactly why we say have the potentiometer at some mid setting as you get started. So there you go, see, it's working okay. Something like that. Okay, now a couple more considerations is, remember, you want to measure the current flowing through that LED, so I'm turning the potentiometer all the way to one side just to maximize the resistance. And so what I would do to handle that is I would then go to the your supply box and get these connectors here that have an alligator on one side and just the bare wire on the other. Same with this one here, alligator on one side, bare on the other, because remember that these two wires here are perfect for going to the breadboard, and these here can clip on to the voltmeter leads, or voltmeter probes. whatever you want to call them. And so I'll get one voltmeter probe out like this and connect it to the red one, and another the black voltmeter probe, and connect it like this. And so now I know that no matter where I connect these two leads into the circuit, they're always going into the voltmeter. And I'm going to say N2 now because I have the voltmeter set up to measure current. So make sure you have that sort of very carefully set. And if I want to go back to my circuit now and integrate this, as you know, when you measure current, you also have to break into your circuit. So I'm going to go ahead and pull this lead off right here and breaks the circuit. But in the current that comes out of the LED on this far lead here, I'm just going to route it right into the ammeter, and then the negative over here will go over to the ground. So see, the LED is back on. I don't need this wire anymore. So the LED is back on, and I'm even seeing some current being registered on my ammeter over there, about 0.31. Now it's not amps, I'm on a milliamp scale here, so it's about 0.31 milliamps, so be careful on how you read your scale. But now what will happen is I have exactly what I want to pull off this measurement now. As I change the potentiometer, so here's that potentiometer again, I'm just going to turn it. You'll see the LED will start getting brighter. See, brighter and brighter it goes. And I can see that I'm getting more current over here now, so it looks like I am successfully reading current through the LED. And that's sort of the way the measurement will go. Now what about the voltage? Well, the voltage will be in a very similar way. That's the current reading. Remember, you also have to break into a circuit to get the current. The voltage will be measured in a very similar way, only remember we want the voltage across the LED. So that's you would take your second voltmeter and get a couple more of those special probes that we have that look like this. I don't mean they're the really special probes, but they're the ones that come in this little bag here that have an alligator clip on one side and just a straight, there's the alligator clip, and just a straight wire on the other. And so this alligator clip can be connected to your second meter in voltage mode, and two of these clips here then can be put across the LED. So you can put both of these clips directly across the LED, both of these alligators clip them directly to your voltmeter, and that's how you can measure the voltage across the LED in parallel with measuring that current. And that's essentially how you can map out the IV curve for an LED. So sort of set there. So just a couple more current measurements here I can take as I maybe decrease the resistance a bit more. The LED grows some more. There you go, those 1 milliamps. So it's still very slow, but then suddenly you can see as I keep turning, the LED is getting brighter and brighter. Suddenly the current just takes off. There you go, something like that. Now it's all the way up to 100 milliamps. So it just took off like crazy, and the LED is really bright like that. And so that's that knee region that you see there, that fast turn on of the diode and stuff. So you want to be turning the potentiometer very slowly at that point to get a lot of data points in there. So anyway, I hope this video helps you see then how you can use the stuff in your kit sort of to cobble together this measurement as you do this at-home lab.